So hello everyone, and thanks for joining me today for this webinar on heat maps and high content analysis for both flow and image cytometry data in FCS Express 7. I'm really glad to be here today with Kaya Ghosh online. Kay is one of our specialists and she will take care of all your questions in real time. So feel free to type your question during the presentation. And of course, if I have time, I will try to reply to your question directly. So first of all, let's start with the agenda of today. So what we will see today? Today we will see how to deal with heat maps, heat map plot, which is the tool that we provide to all our user to deal with high content data. And again, this can be done with both flow and image cytometry data. We will see how to create heat maps, how to format heat maps. You will see we have a really long list of customization that you can use to change the aspect, the aesthetics of the heat map plots. And we will also see some example. So let's get started by giving you an overview of the heat map plot. Again, I want to really reiterate that you can do whatever we are going to see this today with both flow and image cytometry data. So regarding flow, FCS Express can support basically all the instrument nowadays available. For example, it's specifically when dealing with high throughput screening, some instrument, most of them, I would say, save data as FCS file. So each well of the multi-well plates will be saved as a single FCS file. And examples of these are like the Byra Z5, BD, HTS, LSR, the Guava, the Sony. So there are very few example of instrument, and at my knowledge is just the BD Acuri that save the entire plate as a single file. In this case, it's not an FCS file, it's a C6 or C high, but we are still able to import that file as well, as you will see. Regarding the image data, most of the let's say most of the instrument or most of the image analysis software can generate IC files. So IC is the standard for image data, like the FCS for flow data. And example of these file type are like the Nexelon Celigo, the Thermo HCS, or the Yokogawa CQ1. But FCS Express can also deal with other type of image format, like cell profiler, ImageA, Perkin-Elmer, molecular device, and so on and so on and so on. So as you can see, we can deal with really a lot of different file format. If you see, if you have an instrument that is not listed here, if you see that you cannot import those data, just shoot us an email and we will have a look at that. I also want to mention that FCS Express can deal with any plate size. So no matter if you're dealing with 96 well plate, with 384, with 1536, it doesn't matter. You can load it in FCS Express. So FCS Express can recreate that plate no matter which is its size. And if you're dealing with images, it's also good that FCS Express supports multiple fields of view per each well. So the ability to open heat map from high content data comes with an add-ons. So an additional package that it's not included in the professional version. This is because, I mean, only few customers actually are really dealing with high throughput screening. But if you're interested and you want to give it a try, you can simply download the 30 days demo from our website, and you can test it for free for 30 days. Again, because the demo really includes everything and also include the high content package. As you will see, the heat map plots support gate. So you will be able to apply gates to the heat map, and you will also be able to create gate on the heat map. And creating gate on heat map, it means gating on a specific well one or multiple wells, so that you can then use those gates. You can focus on those wells for downstream analysis. Heat map are fully formattable, so you can really display multiple statistics, multiple parameters, and are definitely compatible with batch processing, as we will see. So first of all, I want to start from with a blank layout. As you can see here, it's a blank page. I think most of you already know that FCS Express is really similar to PowerPoint, so I will not go into much detail with that regard. I will go straight and I will open my first heat map plot. As I mentioned in the last page, we can deal with different file formats. So the first format that I want to open is a file that comes from BD Accuri. So it's basically one single file containing all the data. And the extension for this file is C6. So in FCS Express, when you want to insert a plot, and in this case, an heat map, just go to the Insert tab. And you see we have all the different plot type like histogram, density plot, and so on. And we also have the plate heat map. This is what you want to open in this case. So I will just click on that and I will draw an heat map. And now the software is asking me which file I want to load in this heat map. And I'm going to load this file. You see this file, it ends with .c6. I'm selecting here from my drop-down menu the C6 plate file format. But you see we have a lot, like we have FCS plate file folder, as we will see later on. So I will select this file, I will click open. And now all the wells in that plate will be loaded into memory and they will be plotted as a unique heat map plot in my layout. Let me zoom in. And let me also open a classical color dot plot. We will use it later on. So I will just grab it and I will draw a color dot plot here all together in the same page. So you see, this is my heat map. It's basically the representation of the plate that I have acquired. You see I have multiple columns, multiple rows. This is a 96 well plate, so 12 columns, 8 rows. FCS Express is able to find out if you have some empty wells. And for example, in this case, you can clearly see that the first 6 wells here, A1 to A6, and also the latest well in the last row here, they are empty. So they're not even drawn by FCS Express. But all the other well contains at least one event. So the first thing that I want to show you is that you can deal with this plate as any other plot. So you can resize it, you can move it around, you can also duplicate it. So if you right click here, you can duplicate and make a copy of this heat map. Of course, this copy, it's independent. So as you may have noticed, the heat map plot has an X and Y axis. So with the y-axis, you can change the parameters. And for example, what I want to show you now is that you can have multiple heat map plots displaying the same data set, but actually displaying different statistic or different parameters for the same data set. So for example, in the heat map at the top, we are displaying the forward scatter arithmetic mean. In the heat map at the bottom, I'm now clicking on the y-axis and I'm selecting any of the other parameter, for example, the FL2. And now you see that the y-axis is reflecting this change. So it's saying FL2 arithmetic mean, and also the color of each well is changed. So why this? Because the color of each well is calculated based on the statistic and based on the parameter that is displayed on the y-axis. So this is why we call it heat map plot, actually plate heat map plot. So it's very intuitive. So the red means like high value, so it's the heat. Green is indicating cold or low values. And again, it's low or high regarding the parameter that you display on the y-axis. If you want, you can also display a legend. So let me just get rid of this second heat map. I want to keep this analysis quite simple to not confuse anyone. If you want, you can also add a legend, so to show you actually how the color shade refer to the actual value. And this is the first formatting option that I want to show you. So exactly as any other plot type, like color.plot, histogram, density plot, when you want to format it, just select it by clicking inside. You see it's now green bordered. And then go to the Format tab at the top and select any customization you want. In this case, I want to click on Legend. By default, the legend is not visible. You see here, I can select where to make it visible, for example, bottom, and then I can click on Visible. And now you see that I can see actually how the color shade change with the actual value. So for example, green means value that are below 1,003,100,000. Like red means higher than 3,200,000. And if of course, if you change, like if I display now side scatter, now it's updating. So now you see that this it has a completely different meaning, and we have also the color which is changed in my plot. So this is just to show you that first, the heat map can be handled as any other plot type in FCS Express. You can see y-axis, x-axis. You can act on the y-axis to change which parameter to base the coloring on. And you can also format this plot as any other plot in FCS Express. The first option that I showed you was the legend. Now, I also want to show you that there are many other customization. And again, just click on your heat map and then grab any of the formatting option that you have in the ribbon bar. Or in FCS Express, what we have done was to create this dialog and dock it at the right and make it, as you probably already saw, live updating. So this is why I didn't click like OK. I just click on visible and everything updates on my plot. And the beauty of this is that you can keep this dialog at the right, always on top of your screen, and then just change the category. You see, those are the same category that you have at the top in the ribbon bar. So for example, if I want to move and select, for example, specific option, this is the same specific option that I have here. And the specific option that I want to show you are those two. So the first one is, how do you want to orient your plate? You see, now we have different rows and different columns. If I change the orientation to portrait, now it's basically the opposite. So it's just a like a transpose, let's say, of this plate. And another cool thing is this one. If you see that you cannot clearly see the well because maybe they are too small, maybe you are loading a 384 plates and you want to get rid of the white space between wells, you can just uncheck this display space between wells, and the well will be much bigger. Okay, so let me go back. Let's keep things simple. And again, this is my heat map. The next option that I want to show you, the next customization, is about the color level. You see, now we are using a green to red gradient, and the center of this gradient is basically black. But how this gradient is defined? I mean, we can just see that it's clear. It goes between green and red. If you want to customize this, you can just open here the color levels option. So same things as clicking on this button. And I want to show you this. I want to dedicate a few minutes on this because I think it's really useful. So the first option that you have is the actual color level. And you see it says green to red. This is the default. But you see we have a lot. So for example, you have like rainbow, you have flame, you have threshold, you have a new color shade for colorblind, you have red gradient. So this is really useful if you want to create some very nice pictures for like a poster, a presentation, or a paper, and you want to really highlight the message of your experiment. But again, this is aesthetic. I mean, this is the color combination that you want to use. If you go down, you see we have style and scaling. This is more about how you want to, let's say, calculate the color for each well based on the statistic. You see, in this case, it's fixed range, but we have many other different options. For example, mean plus or minus standard deviation. And I want to show you this with the original combination, like green to red. You see, mean plus or minus standard deviation means that you are centering the color shade, in this case the black, on the mean of the whole plate. And of course, the value that we are dealing with are the side scatter arithmetic mean on this plate, because this is what we define on the y-axis. So the side scatter arithmetic mean is calculated for the entire plates, and the color scale is centered on the mean. And then you see the color is extended to higher and lower value with red and green. Another option is percentile. And in this case, the color scale, the color shade is centered on the 50 percentile, so the median, not the mean. I also want to mention this one, fixed range, because I think it's really useful when you actually want to manually define the minimum and the maximum value for your color scale. You see, let's say that, let's say for a scatter. So now what we are displaying, it's basically the color scale of the x-axis on this parameter, like it's the forward scatter. So you see we have cells that goes between 0 and like 18 millions. So let's say that we want color, we want to specify the minimum and the maximum value for our color shade. And I will uncheck this checkbox. So I will not calculate all level based on data. I will click on specify low and high levels. And now I will type whatever I want. So let's say that I want to start with green at 1 million. And maybe I want to start with red at 3 million. You see, now the software automatically calculate the minimum and the maximum around these two values. Now we can clearly see that I have some well that are close to 1 million, let's say green, and well that are really close or even higher than 3 million. So this is really useful when you want to fix, and also, for example, when you are dealing with multiple heat map, maybe displaying the same statistics, so the same parameter, but from different data set, and you want to make the color coding homogeneous between different heat map. So you can fix the minimum and the maximum this way. Another option that I want to show you is this one, the last one, is threshold. So this is good when you want to just set a unique value and just color the well based on whether they are their value is higher or lower. So let's say in this case, I don't know, 2 million. We are still referring to the forward scatter arithmetic mean. The lower level it's green and the upper level would be red. So now you see, I can clearly see that I have a bunch of well in which the forward scatter arithmetic mean it's lower than 2 million, and most of the well, this value is higher than 2 million. And you can change it as you want. You say here, now I know that just 2 well are above 3 million. We will see later on that typing your threshold manually is just one option. But you see here we have a tokens. So I'm not going to do that now because we will have an example later on, but just want to anticipate that you can use token, so live updating values to calculate the threshold. And this is good if you want to automatically update the threshold based on changes that you are doing on your analysis, like for example, moving gates, changing markers, or maybe loading a different plate. Okay, I hope this is clear, but again, if you have any question, just type the question into the question section, so Kaya will take care of you. Okay, what I want to show you now, it's another set of customization that you can use to customize your heat map. So again, let me go back here. And what I want to show you is this other category. It's the overlays category. On this heat map, we now have a single overlay. So you see here in the overlay list, we only have a single overlay, overlay number 1. And what I can show you here, you see statistic parameter and statistic to show. We are displaying the arithmetic mean of the forward scatter. So the statistic parameter is the same parameter that you can change by acting on the y-axis. So you see I can select FL1 and now my dialog says FL1. If I say FL2, my y-axis changed to FL2. The statistic to show, which is only displayed on the y-axis, but you cannot change it by acting on the y-axis, can be changed here. And you see this is a drop-down menu that lists all the available statistic. For example, you can change it to median. Now you see that we are coloring based on the median FL2 for each well. So this is really powerful. And this is just one of the value that you can plot. So you see here, we are just dealing with a single statistic, which is the median FL2, and we are making the color, let's say, proportional to this statistic. But if you scroll down here in the dialog, in the formatting dialog, you see that we have radius parameter, and we also have radius statistic. So there is another aspect of this heat map, and basically of each well, that you can control and you can use to display a new statistic value. So for example, I can say radius parameter, I don't know, let's say FL1, and maybe arithmetic mean. And now what you see in the heat map is that the color, it's telling you the FL2 median. The radius, it's telling you the FL1 arithmetic mean. Or maybe you can select, this is really useful, the number of events. So now you can see, you can have an idea of how many events you have in each well. So for example, the B4, which is super red for FL2, for the color, it means FL2 median high. It's actually containing few events. I mean, fewer events than compare, for example, to B3 or to B7. So you see, in this case, you are basically displaying two different statistics on the same heat map. And if you want, you can use the color to display even more statistic by adding new overlays. So adding new overlays on this heat map is very easy. I usually do it via the data list. You see the data list lists just one file now, but I can drag and drop this file and drop it on top of the heat map. And I can add an overlay. This is the same thing that you usually do with histogram. Okay, there is nothing to be scared about this. This is the same thing. I'm going to add the same file twice. And now you see that in my overlay list, I have two overlays. And if you drag and drop again, you can add 3 overlays. You can add 4 overlays, as many as you want. And the color of each of those overlay can be made proportional to a different statistic. For example, you can say overlay 1 is the median of FL1, overlay 2 is the median of FL2, and overlay 3 is the median of FL3. And now the information that you are retrieving, let me increase a little bit, is that for each of those different slides, each of them refer to a different overlay, so you can retrieve 3 information based on the color coding. Let me make it a little bit, let's say, right this way. You see, each slice, it's a different overlay and gives you a different information. And then you have a fourth information in this case, which is the radius, that we define on overlay 1, which is the number of events in that well. So you see, heat map are very powerful, and you can really use them and customize them to distill a bunch of different statistics and to present your data for publication or presentation. Okay, so I want to switch to the first example. Again, let me go back here. I will remove a little bit these two stuff. I want to make it very easy. And now I want to show you the first example, which is an example that display different customization. Again, we will came back to this example later on when we will deal with batch processing, but so at this stage, just focus your attention on these three heat map. They are displaying the same stuff, so the same data set, the same gates. They're just different in terms of aesthetic. So you see the first one, it's a red-green gradient with percentile style and with the legend here. Here is this, in this one, I've used a rainbow gradient with fixed range. Again, with fixed range is really easy when you want to fix the minimum and the maximum. And just to show you that you can customize this as any other plot, I changed the background. Now it's black, and I changed the line and the font's color of the Y and X axis to white. I changed the font's color of the title, also the font's color of the legend to white. So you see, you can really play with this as you want. And last but not least, as we already saw before, this is a threshold-based color coding, and we will came back here because in this case I've used a custom token, not really a fixed value. But anyway, this is just to show you that this is like a yes or no, or black and white. In this case, it's black and yellow. So it's really useful to customize this type of heat map plot. Okay, so let me go back here. So this is our analysis. So again, we have our plot, we have our heat map. What I want to show you is how to deal with gates. I just mentioned this, but I want to show you that you can create a gate on a standard plot. For example, this color dot plot. Let's say that those are cells. And why not? Let's do another gate. Let's say FL2. So we saw FL2 before. Let's say that we want to gate on FL2 positive cells. FL2 positive, and let's make the gate red. That's fine. What I want to show you is that you can apply a gate to the heat map exactly as you will do for any other plot. So for example, if you want, you can drag and drop the FL2 gates or the cells gate or any gates and drop it on the heat map. And now what we are looking at in the heat map is the FL2 positive population in each well. And you can also see, for example, you see in the last row, so G5, 6, and 7 are empty. And this is telling you that there are no FL2 positive events in those three wells. In all the other wells, you can see events, and indeed FCS Express is able to calculate a color. And in this case, it's FL1 median, for example. But just to be, for example, just to do something interesting, now what we are doing is to plot the FL2 positive cells, and we are coloring each well based on the brightness of the FL2 marker within the FL2 positive population. Okay. Again, if you have any question, just type in. So this was the first example of dealing with gates. You can see it's very easy to apply a gate. You can also remove a gate. So just here at the top in the ribbon bar in the gating tab, you see you can also define the gate here. So if you want to apply the cells gate, that's fine. If you want to say ungate, just select ungate, and now the heat map is ungated. I also want to show you that you can create gates on the heat map. And this is, for example, very great if you want to focus on a specific well or a multiple well. And it's very easy. It's as easy as drawing a gate on any plot. In this case, just grab the well gate type from the ribbon bar. And then draw the gate around one or multiple wells. So now I'm drawing the gate around the B4. You see, I can say this is well of interest. Let's make it sky blue, and I want to emphasize the events on this plot. And let me make like green. I want to emphasize. So since I have created dot plot, color dot plot, you will see the backgating very clearly in this case. And that's it. And then when you've done, you can click on close in this dialog. So now the gate is created, and I can double check this. I can show you this, because if I open, you see the gate view, I have a well of interest gate, and it's not apparent of any of the other gates because I draw it on a ungated heat map. So this is the same behavior for all the gates in FCS Express. And you see that you can backgate, and you can clearly see green events. So those green events are all the events within the gated well. And if you want to highlight the gated well, you can right click on the plate heat map and select show gate, and then activate the well. And you see now it's you have a green circle around the B4. Once you have created the gates like this, you can use it for downstream analysis. So for example, if I open another plot, now this is ungated. If I drag and drop the well gate and I drop it on this plot, now what I'm looking at is the content of the B4. So in this plot, I have all the events from the B4 well. If you want, you can edit the gate. You don't need to redraw it. You can right click and select edit gate, and then grab the gate that you want to edit. In this case, I only have one, so well of interest. And what I can do is to click on any other well. So you see, this is great if you want to navigate through your heat map very easily. But you can also select multiple well, like in this case. You see, just drag and drop. Draw the gate around multiple well, and you will be able to select multiple well at the same time. And when you've done, for example, this is useful if you have replicates. Like, let's say that you have triplicates here. You can just select 3 wells, and now this is the well of interest gate. You can close it, and now the well of interest contains all the events within those 3 wells. So you see, dealing with gates with the heat map, it's not much different than dealing with gates with any other plot. But let me go back and let me delete this gate. So I want to get rid of all those green events, and I want to focus on the red population. So you see, we create this FL2 gate. What we've done was to apply the gate to the heat map. And now what we are displaying for each well is the percentage, it's the median FL2. And in each well, we are only considering the FL2 positive events, because now this gate is applied. But look, if we go back to our overlay formatting option here, you may have noticed that here, we tried like arithmetic mean, we tried median, we tried number of events, but you see here we also have percentage of parent. So now what I'm going to do is to select the percentage of parent, and what you see now in the heat map is that the color is telling you the percentage of FL2 gate among the parent gate. So basically the percentage of FL2 among cells. So when you see red, it means high percentage. When you see green, it means low percentage of FL2 in that well. So this is a really nice strategy if you are interested in the amount of positive cells or negative cells or whatever, but in a percentage. While when you select like mean, median, arithmetic mean, geometric mean, in that case, you are more interested on the expression of a given marker in your population of interest. So far, we just deal with the heat map in terms of, let's say, graphical read out. So we know that you can make the color proportional to a given statistic. We know now that you can make the radius proportional to a given statistic. But what about the actual value? Like now we are displaying in each well the percentage of FL2 positive cells. But what about the raw data? I mean, the actual percentage for each well. Well, you can easily retrieve that information by going in the ribbon bar and opening a spreadsheet. So you see, we have a webinar dedicated to spreadsheets, so I'm not going to into much detail. I just want to mention that it's really similar to Excel. So if you know how to deal with Excel, you will probably know how to deal with this spreadsheet. You see, we have column, we have rows, you can make calculation. What I want to show you is that you can populate the spreadsheet with the actual value displayed in the heat map. And it's very easy. So right click in any cell of the spreadsheet and go to insert. Do not be confused by this one. This is insert token. It's something different. Just go to the insert option and then go to the insert plate, heat map, stat grid. Now we have a single heat map. Oh, sorry, we have a single heat map. So this is why I only have one choice. But if you have multiple heat map, you will see multiple heat map listed there. And you see here, I can select grid, column order, or row order. If you select grid, it's basically the same layout of your heat maps. You see different column and different rows. So those value are the actual value that the color is based on. So if I apply here, for example, a conditional formatting on this, you will see that the color coding, it makes really sense, okay? It's the same color coding that you have on the heat map. But let me go back. I also want to show you the other two options. Maybe just one, but they are pretty intuitive. You see column order, it means go by column, or row order, go by row. So if you select row order, you will have all your values in a column and in a row order. So you see A1 to A12, and then B1 to B12, and so on. So what I showed you now in the spreadsheet can also be done in a standard text box. So if you open a text box, you can right click, insert, plate, heat map, stat grid, select the heat map, and then select anything you want here, like grid layout. What's the difference? I mean, the difference is that this is just a text box. You cannot really do much. I mean, it's good for reporting, for example, but it's not good for calculation. The beauty of the spreadsheet is that you can use it to make calculation. So for example, it's very easy. Average, and then you can calculate the average of these three cells, okay? But it's also good because you can create charts, and this is what we are going to do. But before moving on, I want to show you that the heat map and of course the spreadsheet are both live updating. So if you move a gate, you see that the heat map content and the plot content and also the spreadsheet content updates in real time. And also the calculation that we have done here updates in real time. So this is the beauty of the spreadsheet. But I was mentioning that you can create a chart. So let's say that we want to plot this column versus this column. So we know that this is actually the percentage of FL2 positive. We can make this spreadsheet a little bit nicer. For example, one of the options here is to use the first row as labels. So this means that our chart will actually use these two labels to label axes. And creating chart is very easy. So now that we have all the values in my spreadsheet in two different columns, I can, for example, create a bar plot. And you can clearly see here that I have all the different well, and I have all the different value. And in this case, it says well on the x-axis and percentage on the y-axis. And again, I don't need to mention that this is live updating. So if I move these gates, you see that the bar plot, it's live updating in real time. So this is really convenient if you want to have another type of readout in addition to the heat map. And of course, please keep considering that you can make calculations. So if instead of the single row data you want to plot the average, the standard deviation, or whatever, you can do that. And I want to show you a new chart type that we have added in FCS Express, in FCS Express 7, and it's the box and whisker. So for box and whisker, you can just add a label that define whether a sample it's like group 1, group 2, or whatever. Let's say that those three are control, for example. Of course, if you have this in an Excel spreadsheet, you can just copy and paste. Let's say that this is like drug 1, and let's say these are drug 2, and then you can move on and create different label. Okay. So once you've done that, what you want to do is to use this column and to group similar events together and to plot this on the y-axis. So I'm going to do this. I'm opening a box and whisker, and through the overlay category, I will set to use as a category parameter the group column. And now you see I have my box and whisker, and the box and whisker is live updating as we saw before for the bar plot. So again, this is just to show you that you can fully integrate the spreadsheet in your layout when you're dealing with high throughput screening assay and overall with the heatmap plate heatmap plot. And you can make calculation, you can create some summary statistic, you can create chart. So far we have just seen the bar plot and the box and whisker. But for example, here I have another example that it's an example for regression. So you see here I have a plate, and this is just a picture, but it's useful because it reminds me how the plate was organized. You see in the first column, column 1, I have some negative and positive control. The same thing is for column 12. And in the middle, I have a series of incremental concentration of 2 different compounds. Each concentration for each compound has been plated in quadruplicate. So what I've done here was first opening my heatmap, create some gates. This is a multi-well gates. You see the blue gates, which is the negative. It's actually including 8 well, this one and these ones. And then you have a positive gate, so 4 and other 4 here. In the next page, I've plotted the positive control wells, the negative control wells, and I've used those reference, let's say, sample to create my gates of interest. I've just called them responder and not responder. The idea is that the amount of responder cells increase with the increase of the dose. And just to show you that those are not flow data, but actually they are image data, I've also added some picture plot and some single cells picture here. You see those are all the single cells in my file. And of course, this is live updating. So as I'm going to show you in a few seconds, if I move a gate, everything will update. So in this spreadsheet, I just reported as we did before the grid. So those are the actual value. And then I have made some calculations. So for example, this is the concentration. In this column, I have all the averages. You see, this is the average of the four replicates for the first concentration for drug 1. This is second concentration and so on. I've also calculated the standard deviation just to show you that you can do that. We have tons of formula. And then I have plotted drug 1 and drug 2 as a scatter plot with regression. So you can retrieve any coefficient like the IC50, the inflection point, the plateau, or whatever. And the beauty is that this is live updating. So if I move a gate, like this is the responder gate, you see everything it's live updating in real time. So it's super fast. And again, this is just to show you that you can integrate all the tools that we have in FCS Express, spreadsheet, regression, bar plot, pie chart, pictures with the heatmap plot. Okay. I have another example because, as I mentioned at the beginning, we can deal with multiple plot type, file format. In this first layout that I have created, I have opened a file from Accuri, which is a single file containing all the so all the different data sets. I now want to open these other data sets. So this comes from an instrument that doesn't save all the entire plates in a single file, but just save each single well as a single FCS file. So what I've done here was to add a little piece of information to help FCS Express recreating the plate. And this piece of information is contained in this little text file. So this little text file only tells FCS Express, it's very simple, the plate size. And this is only because the instrument that generated those data didn't save that information in each of those FCS files. So this may happen, so no worry. If your instrument is not saving the plate size within your FCS file, no worry, you can easily add this information um, um, by yourself. So the idea is just creating a text file. We can provide you with this text file that contains these two pieces of information. So $plate row, you can type anything, or $plate column, and you can type anything. In this case, it's a 96 well plate. So the number of row it's 8, the number of column is 12. Once you've done that, and you place this text file within this folder, you see it's called with a specific name. So it's all extra keywords.txt. Then that information is available for FCS Express. So if I open now a blank layout, I will go to the data list, I will open a new file, and I want to navigate to that folder. You see, in this case, I'm not going to open as a BD Accuri as before. I'm going to open it as a FCS plate folder. So it's a folder containing FCS file that should be opened as a whole plate. Now, you can select any file from this folder, like A1 or B8 or B7, doesn't matter. Just select one, and this entire folder will be loaded as a single object in FCS Express, as a whole plate. And the whole plates will be called as the folder name. So the whole plate will be called plate data with multiple FCS file in my example. So I will click OK. Now the plate is opened here. You see plate data with multiple FCS file. I can drag and drop, or I can just navigate to my ribbon bar and select open plate heatmap, or I can drag and drop and then select plate heatmap here. So you see I can create a plate heatmap. I can click on any other plots I want. And when I've done, I can just click OK. And you see this is my heatmap. You see in this case, I have just like 72 wells because I have 72 FCS files. So FCS Express recognize that those wells are empty. So again, this is just to show you that you can deal with high content data, even if your instrument doesn't really say, for example, the plate size. So no worry. If you are in that scenario, just send us an email and we can provide you with that little file with the plate size. Now, this is the last part, so we have almost done. I want to go back to my first example here. So remember, this was the example where we had a few different customization of the plates. Now I want to focus on, first thing, on gates. So in this case, I have created two gates on the heat map. You see positive and negative. I can show them on any heat map just by going to show gates, and you see positive and negative, or select all. You see I can do that also here. Okay, and this is just let's say a further demonstration that once you have those two gates created, so you can see them in the hierarchy, you can use them for downstream analysis. So for example, what I've done in this case was to overlay those two populations. So well A4, which is the red one, which is the positive, and F2, which is the green one, so the negative, I have overlaid those two well on the same histogram. And also you can do that on the same color dot plot. So again, there is nothing to be scared about well gates. You can deal with them as any other gates in FCS Express. So this was the first thing that I wanted to show you with this layout at this stage. And the second thing is that heat map plots are compatible with batch processing. So you see here in my data list, I have multiple data set. So those are 3 different plates. You can have 3, you can have 300, 3000, it doesn't matter. If your layout, I mean, if the scheme in your plates are, let's say, homogeneous, so it means that you want to apply the same type of analysis, the same type of well gates between different plates, you don't need to recreate the same or slightly the same analysis for all of them. I mean, you can just create the analysis for one plate and then use that analysis as a template and analyze all the plates all together automatically with that template. So this is what I've done now with this example. You see, I have few plots like live cells gate, then I have 2 gates, but your analysis can be as complex as you want. And you see, I can click on the second plate to load the second plate. And then I can click on the next plate, like the third one, if I want to have a look at the third plate. And for example, you can see, let's focus on the threshold heat map. You see here in the fourth plate, in the third plate, I have 5 well of interest. If I go back to my second plate, I have only 3, and in the first plate, I have just 1. So you see, I'm not changing anything. And I actually want to point out that the threshold that I set up here is actually based on a token. So if you have a look at these legend, you can see that the threshold value changed between file 1, file 2, and file 3. So how I did that? Remember, here we have color level, and of course it's set to threshold now. So what we have done before was to type in a value. So I type, for example, 1500, and now the well are colored based on that value. What I've done here was to select a token, and in this case I select this threshold token. This threshold token, it's a custom token that I have created by myself here. You can make any formula you want. You see here we have a lot of different functions that you can use, but in my case it was very simple. It was the mean of the negative. Remember, here we have a negative and the positive control, so this is the mean of the negative plus a given, let's say, a given number of standard deviation. In this case, it was 1 standard deviation. But I did this because if you want, you can just type 2, and in this case, it updates. So it will be the mean plus 2 standard deviation. So it's very easy to change it. So this is my threshold token. I just call it threshold. And if I want, I can select it here as a threshold value. So now the value calculated based on this token will be used as a threshold. And since the value of the negative, the mean and the standard deviation change between different plates, you see the threshold change automatically. So this is again another example of automation that you can do in FCS Express. And I want to conclude by running the batch processing. So we have a full webinar on batch processing. So if you are interested, just have a look at that webinar. In this case, I'm going to do something very easy. So I'm just exporting to PDF, but we have a bunch of different exporting options like PowerPoint. We can save, we can print, we can save to Excel, and so on. Once you are ready, you can just click on run. And what the software is going to do is to save my layout for all the plates and generating my PDF here. And you see I have 3 pages. This is plate 1, this is plate 2, and this is plate 3. And I've also added here a spreadsheet displaying the raw data. So it's very easy. So you see, for example, A1, it's actually a well of interest, and indeed the value of A1 is 5,700, which is much bigger, larger than 1,600. Again, those are just examples, but I hope they will help you in getting the flavor of what you can do with FCS Express. So let me just conclude. I want to summarize what we have seen together today. So FCS Express provides you with a very intuitive and easy, user-friendly interface. So, and this is still true for high content data, no matter how complex they are. The heat map allows you to really do a lot of stuff. So first of all, they are compatible with a lot of instruments. They can be as large as any plate size. You can display multiple statistics, either based on the color or based on the radius. So this is very convenient. And you can also create overlay. So you can display different data set on the heat map. And this is, for example, what I've done here in this heat map at my left. And again, just consider that heat map are fully formattable. So if you want to make them cool and nice, you can do that. And again, last but not least, batch processing. So if you're dealing with a lot of plates, not only a lot of FCS file, batch processing can really help and make your life easier. So I think we have done. I don't want to steal too much of your time. If you have any question, we'll stay on live for a few more minutes. If not, feel free to navigate on our website. If you have never try FCS Express, just go on our website and you will be able to download the free trial, 30 days trial of FCS Express. So again, many thanks to all of you. If you have any question, just type in. We will take care of you. Bye.